A galvanometer has a coil resistance of 100 ohm. That is, coil resistance is nothing but galvanometer resistance. Galvanometer resistance G. Therefore, G is equal to 100 ohm. It gives full scale deflection current. That is, full scale deflection current. That is nothing but Ig, which is equal to 30 milliampere. Full scale, it is Ig, this is G. And if it works, so now let us draw, this is the galvanometer with resistance G and its Ig. This is supposed to work as a range voltmeter, and the range of voltmeter, suppose this has to be used as a voltmeter, then it means we have to add a high resistance in series with this one, and the range of voltmeter is given by the expression V is equal to Ig into its resistance plus this resistance G plus R. This is the range of the voltage. So we have to find out this shunt resistance. I mean this resistance which is to be added in series, that we have to find out. So G plus R is equal to V divided by Ig, or R is equal to V divided by Ig minus G. So range, as it is given, a voltmeter of range is equal to, it is required to measure a range of 30 volt. So it means now we can find out the resistance which is to be added to it is equal to V, that is V is equal to 30 divided by Ig. Ig is equal to 30 milliampere, 30 into 10 to the power minus 3 milliampere minus G. G is equal to 100. So this 30 can be, okay, this is equal to 1000. When it goes, this will become 10 to the power plus 3 minus 100 is equal to 1000 minus 100 is equal to 9000. 9000, it is equal to 9000 ohm. This is the resistance to be added, is 9000 ohm. So this resistance is equal to 9000 ohm. A voltmeter has a range of 0 to V volt. That means range of maximum range of voltmeter 0 to V, that is V. This is the maximum range of, it can measure up to V volt with a series resistance R. So this is the galvanometer, a series resistance. This is the voltmeter arrangement with R, and Ig is flowing here. Therefore, its range, maximum range V is equal to potential across this, that is Ig into resistance G plus R. This is the first equation. V is equal to Ig into this much. When now second equation with a series resistance of 2R, it means now this is replaced by here, another, this R is replaced by another resistance of 2R in the same voltmeter with G. This is the voltmeter status now, and this is Ig. So its range now, maximum range is equal to Ig into galvanometer resistance plus the series resistance. This is, now we can say V dash. Now when it is connected, it becomes the V dash. Range is now V dash. with when 2R is connected, its range is equal to 2R. We can call it as a V dash 1. Okay, now we have to find out the relation between V and V dash. Now let us do it for, see, V dash by V is equal to V dash by V is equal to IG into G plus 2R divided by IG into G plus R, or V dash by V. So this get cancelled, G plus 2R divided by G plus R. So now we will make it as G plus 2R. 1 G we added, we will subtract 1 minus G divided by G plus R is equal to 2G, 2 into G plus R minus G divided by G plus R. So therefore V dash by V is equal to 2 into G plus R and divided by G plus R minus G into G plus R. So this get cancelled. So V dash is equal by V is equal to 2 minus G divided by G plus R, or V dash is equal to twice of V minus twice of G into G plus R, because we take it here. It means V dash is equal to 2V subtracted something, that is 2G by G plus R. It means for which condition is satisfied here? V dash with the 2V something is subtracted. It means V dash is less than 2V. Because suppose along with the 2 volt, 1 volt is subtracted, it will become 1 volt. It means V dash is less than 2V. So this is the conditions. It means V dash is equal less than 2V dash. In an ammeter, 0.2 percentage of main current. First let us draw ammeter. So this is the galvanometer. An ammeter means a shunt is attached, then this became an ammeter. This is the main current I. This is current through the galvanometer, and this is current through the shunt. So this is I. Okay, 0.2 percentage of main current passes through the galvanometer. That is Ig. What is Ig? Ig is equal to 0.2% of main current. Since I is equal to main current, that is 0.2 divided by 100 into I is equal to 0.002 I. That is Ig is equal to 0.002. And what about the I minus Ig? I minus Ig. I is 100%. 100%, that is 1 minus Ig is equal to 0.002 I. 0.002 I means it is equal to, on subtracting this one, this becomes 0.998 I. So I minus Ig is equal to this much. To pass through the galvanometer, find the resistance of the ammeter. Resistance of the ammeter means we have to find out this, the shunt resistance. See, from this equation, Ig into G is equal to, because this voltage Ig into G is equal to I minus Ig into S, we have to find out S is equal to Ig into G divided by I minus Ig. See, G is not given because current passes through the galvanometer if the resistance of the galvanometer is G. So this is the galvanometer resistance. Therefore, S is equal to Ig. What is Ig? Ig is equal to 0%, to percentage of I. So Ig is equal to 0.002 into G. I minus Ig is equal to 0.998 is equal to 2 divided by 998 into G, and cancelling 4 times 9 times is equal to 1 by 499 G. So the shunt resistance is equal to 1 by 499 times of the resistance of the galvanometer, or we can write S is equal to a galvanometer of resistance G. There is a galvanometer of resistance G is shunted. This is the galvanometer is shunted by a resistance S ohm. To keep the main, so this is the main current. I is equal to main current, G is equal to galvanometer resistance, S is shunted resistance. To keep the main current constant in the circuit unchanged, find the resistance to be added in series with the galvanometer. It means to keep the main current constant, we are adding a resistance in series. See here, we are adding a resistance in series to keep the main current constant. So here, how this condition can, this and this are in parallel. It means this entire thing will become G into S, because both are in parallel. G plus S. This is GS divided by G plus S to keep the main current constant R. Now, so find the resistance to be in series with the meter to keep the main current constant. To keep the main current constant, now new G galvanometer resistance. New galvanometer resistance G is equal to this one plus this one, that is GS divided G plus S plus R. This is this resistance plus this resistance to maintain this one, and this works as a new galvanometer. So now we cross multiply this one. This will become G square plus GS is equal to GS plus R into G plus S. Okay, this will become this GS cancelled. G square is equal to R into G plus S. Now we need R. This resistance we have to find out what should be this resistance. Therefore R is equal to G square by G plus S. This is the value of the resistance R. So that with this arrangement, if you are adding in series an R, this with the resistance, value of the resistance is this one.